I've been building AI tools for a while now. Finance trackers, stock screeners, habit systems, voice notifications, all of it running locally, all of it actually useful. But I hit a wall. The tools were getting bigger, more files, more edge cases, more moving parts, and I kept getting stuck. Not because I couldn't figure out what to build, but because I didn't want to spend hours grinding through the implementation. So I changed the workflow entirely. I now have two AI agents working for me. One designs the system, the other builds it. I direct them both and review the result. Today I'll show you exactly how that works and whether it actually holds up. Two AI agents. One thinks, one codes. On the left, Claude. It reads what I describe and designs the system, architecture, file structure, edge cases, all of it. On the right, Codex. It takes that design and writes the actual code. My job is to tell them what I need. Here's how it works. When I need something built, I describe it to Claude, my primary AI. Claude turns that description into a proper technical spec. Architecture, file structure, inputs, outputs, edge cases, the stuff I'd spend an hour figuring out on my own. Then I take that spec and hand it to Codex, OpenAI's autonomous coding agent. Codex reads the codebase, writes the implementation, and returns a diff. No back and forth, no explaining the context twice. Just, here's the spec. Let me walk through a real example. I needed a tool that reads stock listings from a Norwegian site, scores each one with AI, and surfaces the top candidates. I'd been putting it off for weeks because the scraping plus scoring logic felt like a long afternoon of work. Step 1. I describe what I want to Claude. Not a spec, just what I need in plain language. Claude asks a couple of clarifying questions, then produces a full technical spec. 40 lines, inputs, outputs, file structure, error handling, which AI model to use for scoring. I read it, confirm it matches what I had in mind, and that's the design phase done. I didn't write that spec, Claude did. My job was to describe the problem and say yes. Step 2. I copy the spec into Codex. In the terminal, I run Codex and paste it as the task. Codex reads the existing codebase, writes the implementation, and returns a diff. 4 files, 300 lines, about 90 seconds. And the structure was correct. TypeScript types matched the spec, error handling was there, it used the right model and retry pattern. Step 3. I review. This part is mine, and it's not optional. Codex follows the spec, but it doesn't know my whole system. I check 3 things. Does it match what Claude spec'd? Does it integrate cleanly? And did anything get missed? One issue. I've now used this workflow on 4 tools in 2 weeks. The Fin Screener, a finance tracker update, a keto food deals tracker, and a workout analyzer patch. The pattern held every time. Codex was structurally correct when the spec was precise. Every failure came back to the same thing. I hadn't described something clearly enough to Claude, so the spec was vague, and Codex filled in the gap wrong. One thing that tripped it up early. My PAI tools use a specific config loading pattern. Claude didn't know to include it in the spec until I mentioned it. Second time I said use the finance tool config pattern as reference. Problem gone. The lesson I took from this: the quality of what Codex builds is almost entirely determined by what Claude spec'd. And what Claude specs is determined by how clearly I describe the problem. The bottleneck moved upstream, which is exactly where I want it. Use this if you're building tools in an existing codebase and the bottleneck is implementation time. The workflow is genuinely fast, and the spec discipline forces clearer thinking, which makes the tool better before Codex even starts. Skip it if you don't know what you're building yet. If the problem is unclear, a fast build just locks in the wrong thing faster. Like and subscribe. We're building and breaking things every week.